Hello everyone. Let's today talk about the Lipschitz extension problem. First of all, we review the definition of Lipschitz functions. What does mean? Let our domain X is Rn. A function f from this domain to R is Lipschitz continuous. Lipschitz continuous. On X in our domain, and we will write it f belongs to Lipschitz X if there exists constant L from 0 to infinity such that for all x, y from this domain X, the inequality fx minus fy satisfies less or equal L times x minus y. This is definition of Lipschitz functions. Any such L is Lipschitz constant, and the least, the minimum of this constant, we write like Lipschitz f in the domain of X. Okay, now the Lipschitz extension problem. What is this? Given function f, which is Lipschitz on the boundary of U. Now our U is our open and bounded domain, something like this, and f is a Lipschitz function on the boundary. Lipschitz extension problem is we have to find function U, which is Lipschitz function in the domain U bar, it means all domain, such that U is equal to f on the boundary of du, and Lipschitz U, the minimal, this one means minimal Lipschitz constant on the whole domain is equal to Lipschitz f on the boundary. How to understand this? For example, we have something like this domain, and our boundary is this one. This is our boundary, and we have f in this boundary, and we have to find U such that exactly same with f on the boundary are inside or in the boundary everywhere this Lipschitz constant is the same. Minimal Lipschitz constant is the same. It means when we increase our domain, like our domain is becoming now not only boundary but whole our domain. However, our Lipschitz constant still is same with a boundary. Okay, let's solve this problem. This is Lipschitz extension problem. How we will solve it? Suppose exists such U which solve Lipschitz extension problem. Then if y is on the boundary of U and x is in whole U bar, in whole domain U bar, this big U means our domain, then U x less or equal f y plus Lipschitz f du times x minus y. Why this is true? Because if you solve this Lipschitz extension problem, then ux minus fy, y is in the boundary, is less or equal than Lipschitz f du x minus y. If x also in the boundary, then the problem is solved because in the boundary fy is equal to u of y, ux minus u of y is less or equal, and Lipschitz of f on the domain, on the boundary is equal to Lipschitz of u in whole x minus y. So this is true for all x and y only in the boundary. Okay, now we have this one, this formula. Second point. Let's z is on the boundary and x is in whole domain. Then fz minus Lipschitz f on the boundary times x minus z is always less or equal than u of x. How we prove this one? Our f z is in the boundary, it means it's equal to uz. Ux we can write in this side. Ux, this is equal, less or equal than Lipschitz of u on whole u times z minus x, and x minus z is the same because it's absolute value. So it works for all z in the boundary and x in all u. Therefore, this formula is also correct. Now let's define fzx is equal to fz minus Lipschitz f in the boundary x minus z for all x in whole domain, and gy is equal to fy plus Lipschitz f on the boundary x minus y for all x in whole domain, but our y and z is in the boundary. Now we prove that fzx and gyx are Lipschitz function, Lipschitz continuous. How we prove it? Just by definition. Fzx minus gyx absolute value is equal to, we put fx minus Lipschitz du x minus z minus fy minus Lipschitz du times x minus y is equal to fx minus fy minus Lipschitz f du we can take out from brackets x minus z plus x minus y. Sorry, here was fz. Here also fz. Here we are taking two different points, therefore I take this one, not x, but x here, like this. We have to prove each of these functions is Lipschitz. So here should be z, also here x minus z. and this one goes with this one. Here x and x prime. And this is equal to Lipschitz f du times x minus z minus x lambda minus y. We know inequality absolute value minus absolute value b is less than a minus b, triangle inequality. Therefore, this is equal to less or equal than Lipschitz f du x minus z. Sorry, here also z. Z goes with z, x minus x lambda. So this is definition of Lipschitz. Same situation when we have gy x minus gy x prime. Let's take prime is equal to fy plus du x minus y minus f y plus minus Lipschitz f du x prime minus y. And here it will be fy goes with fy, Lipschitz f x minus y. Absolute value x minus y minus x prime minus y. Again, we use triangle inequality. It will be Lipschitz du x minus x prime. So we proved why we defined this function. Next lessons we talk about Max, Shane, Whitney. Thank you for attention.